Hey, how's everyone doing? Welcome back to DELSQUARED SI, and this time I have made a stroboscope. Well, I have not actually made a stroboscope, but I'm just planning to make a stroboscope. But I have just run a few simulations and I have just started to work with the hardware right now. So I would like to show you my hardware for now, and that's what I want to show you. So we'll be using the multi-sim software to look at all the aspects of my circuit. So here we have the first one being a voltage source. So we are using this connector, 9 volts connector, and that is being connected to the 5 volts 7805 circuit. And then we have this voltage regulator, and then we have the 5 volts reference, and then we have these push buttons over here, which are going to control a lot of aspects of all the aspects of this stroboscope. The first one being increasing the frequency in steps of 100, decreasing the frequency in the steps of 100, increasing the frequency in the steps of 10, decreasing in steps of 10, increasing steps of 1, and decreasing in steps of 1. So with this we can finally fine-tune the strobing effect of the LED, which we are finally going to control. And the stroboscope is generally used to find the speed of rotation of shafts, and also also find the slip of induction motors. So this is a very useful device. So here we have these 7-segment displays which are going to display the speed in RPM, and that is what we actually want. And see, there is one very important design consideration while doing this, and that is, see, we have 4 7-segment displays over here. So this means that we will have to use 4 BCD to 7-segment decoders, but that is expensive, that is unnecessary. So for reducing the cost, so we go for just one BCD to 7-segment decoder, and we actually use the beauty of multiplexing over here. So these transistors here control or activate the 7-segment display whenever it is needed, and the data is whenever for example, whenever this 7-segment display is activated, we send data to the decoder pertaining to this digit, and then whenever we switch on this transistor, then this is enabled, and then we send information pertaining to that digit to the decoder. And all the processing stuff pertaining to the whole process is being controlled by this single 8051 sitting over here. So this is weird because I think you are not going to see any wires over here except for these wires here. So the reason is that I have tagged them all so that it will look neat. But see, this microcontroller is connected to this device, which is the BCD to 7-segment decoder, and also this is the specifications I am working on. That is, port 0 is connected, port 0 lower is connected to the decoder, port 0 upper is connected to the switching transistors, port 1 lower is connected to the switch array, which is this one, and port 1 is connected to the LED array. But LED array, we are not using any kind of an LED array, we are just using one single LED. I'm sorry about that. And then this is the 250 ohms current limit resistor that we are using for the LED, and then that's about it. It's so simple. So this is my final PCB design. I have made it on the Ulti board. So this might not make any sense to you whenever you look at it the first time. You look it for the first time, but I will show you the most interesting part of Ulti board, and that is the 3D mode. So this is what we are talking about. So we have these 7-segment displays over here, and this is the decoder. This is the decoder. This one is a microcontroller. These are the switches that control the switching of the switching rate of the LEDs, and this microcontroller is going to serve the purpose of strobing this LED and also converting the frequency of strobing into RPM and displaying it over here via these transistors. And you know what, this microcontroller also controls the transistors, and this is the power jack. I'm sorry, this, one second, let me get this right. Yeah, so this is the power jack, and this is the 7805 voltage regulator. I'm not using any kind of a heatsink over here because this system is not going to heat up, I'm sure about that, at least. And this is the first side, and then there is going to be the side below this. See, these are the connections. So this looks like a rat's nest. So sorry, this looks like a bird's nest. It is seriously complicated, but that is where, you know, a sense of satisfaction comes. Yeah. Thank you for watching, and I'll keep you posted on any further developments in this project. Thank you.